The time was August 1985. The old provincial government building was mostly constructed before the war and was facing several problems such as serious deterioration and lack of proper office space. To overcome the problems caused by the deterioration of the building and the dispersed and confined spaces of the old provincial government building, to modernize the provincial government, the Tokyo province decided to construct a new main office building. On August 1985, the basic plans for the construction of Tokyo Metropolitan Government Building was announced. Through these plans, the province of Tokyo proposed to move administrative functions such as the main office and provincial assembly to Shinjuku district while placing a forum with a citizen hall capable of holding an international conference at its core in Marunouchi district. Following this announcement, plans for creating a Tokyo International Forum in Marunouchi district got underway in detail. In designing the building to not only guarantee a symbolism and create topicality, but to also increase participation, the idea of holding an international design competition was proposed. Under the official approval of the International Union of Architects, the first ever design competition in Japan was held. As the result of this competition, Raffaele Vignoli was selected to overlook the designing of the building. Hello, we are Team 1. As we talked about last week, we're going to take a close look at underground work. Before we move on to our main topic, we need to look at the first step of the construction process, which includes the architect's departure from postmodernism, problems encountered on site like bubbles and artifacts, and three main points of focus during the construction process. Afterwards, we will conduct an in-depth analysis of underground work, focusing on top-down method and slurry wall installation. Now, let's start with the historical background behind the construction of Tokyo International Forum. The designing of Tokyo International Forum started on March 1990. The actual construction began on June 1991 and ended on May 1996, taking a total of 44 months. The Japanese structural design firm SDG handled the structural design of the Tokyo International Forum. As for the actual construction, the two main construction firms that took part in the construction were Obayashi Corporation and Daejeon Construction. Obayashi Corporation was in charge of constructing the glass hall, while Daejeon Construction was in charge of constructing the rest of the halls. The resulting building is 57.8 meters high and its basement is 20.8 meters deep. The budget for this construction was 150 billion yen, which approximates to $180 million. On March 1990, the province of Tokyo signed the contract with Raffaele Vignoli on the basic designing of the forum. The structure was mainly composed of reinforced concrete, steel reinforced concrete, precast concrete, and pre-stressed concrete. Raffaele Vignoli was strongly critical of the postmodernistic trend that was prevalent and widespread within the field of construction at that time. This led him to commission the basic structural design to SDG, a structural design firm led by Watanabe Kunio, who valued designing on the basis of technology engineering. However, they soon came across a problem. When first designing the building, they estimated that the price of the steel frames wouldn't exceed 700,000 yen per ton. Because of this, they set the budget of the steel frames on 700,000 yen per ton, but there were one variable they could not foresee. On February 1991, as they were preparing to begin the construction, the price of the steel frames increased to 2.8 million yen per ton, 4 times the planned budget set for the steel frames. This was due to the Japanese asset price bubble, which showed no signs to die down. To combat this, the construction team decided to initiate an excavation search for historic sites based on the information that there was a house of daimyo, an aristocrat of Edo period, in plot of land. This decision was based upon the construction team's accurate estimation on the early months of 1991 of the collapse of the bubble caused by Japan's restrictions on the total amount of loan. It correctly anticipated that this would lead to a sharp decline of the price of steel frames. The price of steel frames would drop significantly down to the original budget of 700,000 yen per ton. During the excavation search between June 1991 and October 1992, the construction team immediately began the construction process on October 1992 as soon as their budget conditions were met. They first planned to use a 10 meter by 10 meter grid on construction, but soon realized that a 9 meter by 9 meter grid would be more beneficial, as it is considered to be more appropriate size for a more efficient design of steel frame structures, allowing for a more economical placement of structural elements. Not only that, since most structural elements come in sizes that fit grids of multiple of 3, this decision would also cut unit costs. With their newfound plans, the team was able to begin in construction, but they were soon met with more problems. The plot of land on which the forum was to be built was surrounded with 4 underground railroads, and the forum itself was designed to be complex steel frame-based structure, leading to several complications in the initial construction process. To solve this, several efforts have been made. The jack-down construction method being used for the ground roof of the glass hall, and the sliding formwork method being used for Hall A's roof are some examples of these efforts. With the effort of the construction team, the usage of state-of-the-art methods, the construction ended in 44 months. The construction was processed by focusing on these 3 keywords: an earthquake, wind force, and vibration. As we keep going on the study, we can get how these issues were resolved during the construction process and what trials and errors were encountered during this process. Okay then, this time we'll handle the foundation work and next time will be the superstructure. So, let us tell you about the underground construction first. The underground part of the Tokyo International Forum is a reinforcement concrete structure with 3 underground floors, and due to the narrowness of the site and the subway line adjacent to the site boundary, they used top-down method. So, let's look at the top-down process of the Tokyo International Forum step by step. Here's 5 steps of top-down method they used in this construction. The ground is gradually dug up and the underground level is lowered. At the same time, the steel structure is raised. The floor slab is built, so the ground level is also raised. At the start point of construction, they built a diaphragm wall with concrete, and this is the first important point of the underground work in terms of vibration problem we mentioned. The method they used to create the diaphragm wall is called slurry wall installation. Before we get deep into this story, let me explain the remaining steps, and then let us get back. The cross section also tells us about pilling the underground columns. Considering the module of Theater Hall, they made a grid with a width of 9 meters. And specifically, they built an 18 meters grid for the concourse hall of first basement floor and a 4.5 meter grid for stability at the deepest underground level. You can see the pilling works of whole columns with this 3D modeling of construction process we made. The second cross-section shows us the temporarily placed concrete. Thanks to this temporary concrete slab, there's no need for scaffolding. Also, it allows for safe working postures and improves work efficiency. This concrete slab is for the subsequent work: the superstructure, crane, and PC bridge slabs. And they dug the center part of the ground, which is for the concourse hall and the open plaza. It is because steel structures had to be built on both sides. Now is the third step. They built a V-shaped columns in the concourse hall section on the second basement floor. The reason why the shape of the column is V is for the open space, which the architect Vignoli has emphasized. And they also made the ground level floor slab, which leads to the next process. They can make a PC bridge on the first basement level thanks to the strong axial force created by the V column. This PC bridge is another important point about construction technology and has a big role of enduring earth pressure. So, let us handle this issue next week. Coming back to the fifth step, they finally dug the ground of the whole site deep to the 21 meters. So, the underground construction has been finished. Now that we've looked at the steps of underground construction process, let's talk about the slurry wall installation, which was in step 1 that we mentioned earlier. The diaphragm wall was constructed a little away from the main structure to reduce vibration from the subway. So, what was the requirement for this process, considering the conditions of the site? It is that the site is located at the center of the city, so the construction has to be done in lower noise and vibration, and it had to be strong for the earthquake. So, the side, the construction company has used the slurry wall installation. It is the method using the bentonite as a stabilizer which enables to pour the concrete into the deep ground, so that eventually we could make an underground concrete wall without digging the whole site soil. Here is the process of it. First, they constructed 2 parallel guy walls made of low reinforced concrete casted on the working platform. These narrow guy walls have rules that it outlines and precisely defines the structure to be built. And it also makes a space for a BC cutter to get inside the underground. Second is excavation phase, which is made of 1 or several overlapping bites forming a panel, with the help of a support fluid, the bentonite. Bentonite forms a local cutoff barrier on the sides of the excavation. This barrier keeps the excavation open by applying a hydrostatic pressure that counteracts with earth pressure, which tends to collapse the sides of panel. Third, the steel reinforcement is put and the concrete is poured by the tremie pipe. At this time, the tremie pipe should be deeper than the concrete paste for preventing the material separation. While the concrete is poured, the bentonite fluid naturally goes up and is removed by the pipe connected with a BC cutter. As the concrete fills up, separate the pipe joints and continue filling the concrete. Lastly, this work is repeated along the site boundary. The important point is that to prevent the imbalance of rigidity between the side walls of the excavation, the work should be done in an intersectional way. These are the primary zone and those are the secondary zone. On this diaphragm wall, the vibration isolating pads are installed and the perimeter wall is constructed apart from it, so we can solve the noise and vibration problem effectively. Okay then, next week we'll keep going on about the underground construction, especially about the perimeter formwork and how to reduce the vibration. These are also very important points about the underground construction. Thank you for listening. This was Team 1.